Hi everyone, it's your physics teacher Dr. Kumar, and today we are going to discuss about electricity and magnetism. So let's begin. So everyone is familiar with the fact that when we put off our clothes made of terylene or nylon, a crackling sound is produced. Similarly, when very dry hair is combed with a comb, similar crackling sound is produced. And this is due to the fact that comb and the synthetic clothes are strongly electrified due to friction. In general, when a body is rubbed with a different body, electric charge is produced. This quantity of charge produced depends upon the nature of body and also on the atmospheric condition. The presence of electric charge on a body can be detected with the help of electroscope. So electric charges are two types, that is positive and negative charges. And according to Coulomb's law, similar charges repel each other. For example, if we bring two positive charges close to each other, then both these charges will repel each other. And similar cases happen also for negative charges. But in case of opposite charges, for example, if we bring a negative charge in the vicinity of a positively charged body or positive charge, then these two will attract each other. So electric charges have some properties. So the first property of electric charges is the additivity of electric charges. So which means that point charges are scalars, and this can be added algebraically like discrete entities. The second property of electric charges are the conservation of charges, which means that in isolated system, the total number of charges is always remains same. And the third property of electric charges is the quantization of charges, which means that the charge is always represented in the form of Q is equal to Ne, where E is the electric charge and N is some integers. And electric charges are basically like discrete quantities, and it is not a continuous quantity, which means these are quantized particles. Okay, now let's talk about electric field and electric potential. So what is an electric field? So an electric field is a field or space around an electrically charged object when any other electrically charged object will experience force. So for example, this is a positive charge, and this region is basically known as the field of these positively charged particles. So if you bring any positive or negative charge inside this field region, so that charged particle will experience a force due to this positively charged particle. And the force, for example, suppose this positive Q0 charge, we are bringing it from infinity to any one of the points inside this field region, then this Q0 will experience a force due to this positive Q charge. And the force experienced by this Q0 positive charge is known as the electric field. That is, electric field is basically defined as the force per unit charge. On the other hand, electric potential is defined as the amount of work done needed to move a unit positive charge from a reference point to a specific point inside this field without producing acceleration. So if W is the net work done to bring a positive charge Q or Q0 from a point which is beyond this field regions to a point B or any point inside this field region against the electric field, then the electric potential can be defined as V is equal to W by Q, where W is the net work done to bring this positive charge from infinity to any point inside this field region. The SI unit of electric potential is known as volt. So if we place a small positive charge in an electric field, it will experience a force in a fixed direction. In case if the charged body is light and free to move, it will start moving in the direction of the force. The path which this charged body adopts is called lines of force. So we can define an electric lines of force as the path along which a unit positive charge would tend to move when free to do so in an electric field. So always remember that the electric lines of force for a positively charged body, it is always directed outwards, whereas in case of negative charge or negatively charged body, field lines are always directed inwards. So from the electric lines of force, we can find out the direction of the electric field. For example, suppose this is the lines of force which is generating from, or which is directed from positive charge to negative charge, and suppose you want to find the direction of the electric field at this point P. So what you have to do only, so you have to draw a tangent at this point P, and the direction of this tangent at point P, it will give the direction of the electric field. Similarly, the direction of the electric field at point R, it will be directed this way. So this is the way where you can find out the direction of the electric field from the electric field lines. So there are some properties regarding the electric field lines. The first property of these field lines is that no two field lines intersect each other. Now suppose you consider that electric field lines or two electric field lines intersect at a point. So at that point, if you draw a tangent, so that you can draw two tangents at the intersect points, and therefore you will get two direction of electric field at the same point, which is not possible, which is impossible. So therefore, no two electric field lines intersect each other. Second one is that they are always perpendicular to the surface of the charge. Suppose if there is a charged body, the electric field lines are always directed perpendicular to the surface of that charged body. The third property of these field lines is that the magnitude of the charge and the number of the field lines both are proportional to each other. And the fourth property of field lines is that it starts from the positive charge and end at the negatively charged body or negatively charged particles. So guys, till that we have learned that electric charges are two types. So electric charges can produce field lines. Now what will happen if the electric charges move in a certain direction? So if the charged particles move in a certain direction, so they will produce a current. So basically, an electric current is the rate of flow of electric charges in a circuit, which means that the number of charges moving in a certain direction per unit time is known as the current or electric current. So how the charged particle will move? So suppose this is a conductor, and suppose you join the two ends of this conductor to the positive and negative terminals of the battery. And we all know that conductors always have some free electrons which are responsible for producing electric current. So when you connect this conductor to a battery, so the electric charges, that means the electrons or the free electrons, will accelerate towards the positive terminal of the battery and they will form a current. So the SI unit of current is known as the ampere, and in case of conductor, this current, the flow of current, and the potential difference which is applied at the two ends of this conductor is given by the Ohm's law. So basically Ohm's law says that the current flowing through a conductor is proportional to the potential difference applied on the two ends of this conductor. So if V is the potential difference between the two ends of this conductor, then this V is proportional to I, which is the current flowing through this conductor. And if we replace this proportionality sign to equality sign, then we have to put a constant, which is here the R, and this R is known as the resistance of this conductor. So this is a linear equation. So if you plot current against the voltage or the potential difference applied on the conductor, then you will get a straight line starting from the origin. And the SI unit of this resistance is known as the ohm. So for example, this is a simple circuit. So we are applying 12 volt potential difference at the two end of this resistance, which is 24 ohm. So from Ohm's law we can calculate how much current will flow through this circuit. So following the Ohm's law, we can calculate I. It will I equal to 0.5 ampere. Now let's talk about what will happen when current flows through a conductor. So from our discussion, we have learned that conductors have free electrons, and when you apply a potential difference between the two ends of a conductor, then the electrons move towards the positive terminals of the battery. So when the electrons move inside the conductor, they will collide with the atoms of the conductor, and due to their collision, a significant amount of heat generated, and the amount of heat generated due to the flow of current through the conductor is given by Joule's law. And according to Joule's heating law, the heat generated due to the flow of current through a conductor is directly proportional to the square of the current flowing through the conductor when the resistance and the time remains constant. Again, the heat generated due to the flow of current is directly proportional to the resistance of the conductor, and it is also proportional to the time. That means how long the current is flowing through the conductor. So if we consider all these three conditions in one, then we'll find that H is equal to I square RT divided by J, where J is called the Joule's constant. And this is called the Joule's heating law, which means that if the resistance increases, the current, if the resistance increases, the heat will generate more. On the other hand, if you increase the current, then heat will also increase, and correspondingly, if you let the current to flow for a long time, then more heat will generate. So this is all about Joule's laws of heating, and this is the end of our short video on electricity and magnetism. So let's see in the part 2 of electricity and magnetism lecture.